Geometry lesson 4-5. I'm going to give you two proofs that we can use. We've got given M to P bisects, think about what bisects means, it cuts it in half, the angle of NML. At that exact same time, also given to me is the fact that L to M, the line segment L to M, is congruent to the line segment N to M. So let's go ahead and label what we know. If MP bisects, M to P is bisecting NML, that means that this angle and this angle must be exactly the same because it's cutting that angle in half. We also know that LM, which is here, has to be the exact same measurement as NM. So that's all the given information, all right? And if we want to prove this, we'll start off with our statements and our reasons. So I'm abbreviating them a little bit. Statements and reasons. First of all, the statement, we know that MP is bisecting angle NML. So MP is bisecting angle NML. That's given to us. Alright, next we have that angle LMP is going to be congruent, right? Because we're dealing with, or equal, I should say. It's going to be equal to angle NMP. And the reason we know that is we're dealing with definition of a perpendicular bisector. I'm sorry, angle bisector. Alright, so that's why we labeled the two red arcs in here. It's because we knew that because that was an angle bisector, it would be cutting it in half. Alright, next, we've got the fact that the middle line, MP, is congruent to itself. It's the same on both of those triangles. Remember, this is a triangle here, and that's a triangle there. So both of those are the same triangle, they're congruent. We would want to say that that's reflexive. It's a reflection of itself on both of those triangles, so it would be exactly the same. Next we have LM. LM is congruent to NM. And the reason we know that is that was given to us. Given information. And now, let's go ahead and label. That's congruent to itself. You can now say triangle NMP is congruent to triangle LMP. And the reason I know that, side angle side. Okay, so I've just proven that the two triangles are exactly the same. They're congruent. And remember what congruency means. Every single angle and every single side is going to be exactly congruent on the other triangle's corresponding parts. I'm not trying to prove that the two triangles are the same. I'm trying to prove that these two are the same. But fortunately, now that we know the two triangles are identical to each other, I can do that. I can get my final part, which is LP is congruent to NP. And the reason for that is, and this will be a big one, corresponding parts of congruent triangles are congruent. If you actually have two congruent triangles, then every part of them is going to be congruent with a corresponding piece on the other triangle. Corresponding parts of congruent triangles are congruent. N is the same as L. this line is the same as that line. The middle is the same for both triangles. That side is the same as that side. Because I proved they were congruent, it made it so I knew they were all going to be the same. One more proof. We're now trying to prove, according to this situation, L is the midpoint of Jn, and if it's in the middle of Jn, that means that this entire distance here is exactly the same as there. And we have P to J, which is here, is exactly the same as Q to N, which is right there. We are also given P to L is the same as Q to L. And we are also knowing that angle PKJ, P to K to J, is a right angle. And QMN is a right angle. We are trying to prove that PKJ, triangle PKJ, we are trying to prove this triangle is exactly the same as QMN. Great job on that one. God, last try. Those are the triangles we're trying to prove are exactly the same. So let's save ourselves a little bit of time and let's see what we got here. Number one, we've got the given information. So let's just say we've got given. Right? All that given stuff. And then we could say that JL, J to L, is equal to what? The L to M, right? JL is congruent to L to N. And the reason we know that is the definition of midpoint. Definition of midpoint. So we've now proven that that entire distance across is the same, right? From there we want to say that the two triangles. Now, do you have anything that you know is going to be the same based on what you have up there? Any situations where you're like, boy, I sure know that I've got some stuff that's the same. If you think about it in the triangle realm, you could say that angle JPL, this one here, because remember, I just proved that that side, this entire distance across, is the same as that side. So I have three of those sides. So triangle JPL is congruent to triangle NQL. And the reason for that is side, side, side. I've got one side, two sides, three sides that match up with one side, two sides, three sides. And remember, I put them in a specific order on purpose. J matches up with N, P matches up with the Q, and L matches up with L. You've got to make sure that that order is pretty important. Okay, our next statement, because of that, the fact that I know the corresponding triangles, parts are all the same, that would mean that if this whole triangle is the same as that one, then all of this up here is the same as all of that there, that this is the same as this. There's all kinds of things that are the same. Okay? Because they are congruent triangles. Let's get a little bit more space here. So we'll go and we'll say angle J is congruent to angle, according to this, J is congruent to angle N. Alright, angle J, since it's a corresponding triangle to the other one, that means angle J corresponds to angle N. Alright, and our reasoning for that, remember we're dealing with corresponding triangles, so we would have corresponding parts of congruent triangles are congruent. Exactly the same reason we used on the last example. Alright? Is that enough to prove those two triangles are congruent? The answer, getting close. Alright, move this down a little bit more. So now L, angle PKJ, top, P to K to J, remember this, right there, P to K to J is congruent to angle QMN Remember what we had up here, we said they were both right angles. So the fact that they're both right angles means that they are congruent to each other. That's the right angle congruency theorem. Right angle congruency theorem. And the last one. I have now proven that I have a congruent part to a congruent part. I've proven I have a congruent part to a congruent part. And I have a side that's congruent to each one of them too, because that was given. Remember, that side is not included between the two angles. It's a non-included corresponding side. So we are talking about saying, our final piece, PKJ is congruent to the part QMN, triangle QMN. And the reasoning behind that is angle, non-included corresponding side. And those are two proofs, pretty detailed. You'll notice this part's kind of something new here. Corresponding parts of congruent triangles are all going to be corresponding parts congruent. Okay? Take any piece of one triangle that corresponds to another one and they're congruent, and they'll match up. Proofs are not easy. They take practice. Keep working at them. Ask lots of questions about them. Remember, you want to take the given information, try to label it on the diagram, and then go from there and give reasons for your logic.